Meet SAE International. You might not know us, but we've been with you. For the past 100 years, we've been revolutionizing transportation and mobility, partnering and supporting the dreamers, innovators, and can-doers who are changing the world. It's the child whose future career as an engineer will be shaped by our STEM education programs. It's the businesswoman boarding her flight with peace of mind, knowing that our committees have created the standards that ensure she gets from Detroit to Delhi and back again safely. It's the parents-to-be who are sleeping soundly, knowing that their electric car is fully charged and ready when it's go time. Driven by a passion to advance mobility knowledge and solutions, SAE's global community of over 200,000 engineers, technical experts, and volunteers continues to develop and curate the most reliable and comprehensive collection of engineering resources and consensus-based standards on Earth. The next mobility revolution is upon us. Connected and automated, electrified and sustainable. SAE will be here, as we have for the last 100 years, moving the world forward.
Hello and welcome everyone to the Formula SAE Vehicle Performance Development and Tuning Event Overview. Thank you for joining us today and to the SAE Detroit section for hosting this event. I am Matthew Meyer, your moderator. Just a little bit of background about me. I'm an SAE member from the Detroit section. I graduated from Lawrence Tech University. I was in their Formula SAE program and was also the SAE student chapter president. And today, I now work at General Motors as an EV propulsion lead engineer. Before we start, I just want to address a couple housekeeping items. All participants are muted with the camera off to keep the integrity of the meeting. Please do not attempt to unmute yourself or turn on your camera during this discussion out of the courtesy of our speakers. We do encourage you to use the chat function to ask any questions you may have. You may start now. Also, for your benefit, this video is being recorded and will be posted on the SAE Detroit section's YouTube channel at a later date. Today, we're going to be hearing from Tom Schlinderly, Lead Development Engineer at General Motors, and Bill Wise, Chassis Control Technical Lead Performance Engineer, also at General Motors. They will provide you an overview and Q&A on the vehicle development process and key testing techniques to help you produce repeatable results. Welcome, Tom and Bill. How about you tell us a little bit about yourselves?
Hey everybody, Tom Schinderly. I am a lead development engineer at GM, mainly focused on Cadillac electric vehicles. A lot of them are future vehicles and haven't been revealed yet, so I'll just leave it at that. Lead development engineer is responsible for all performance metrics, anything from seat comfort to noise and vibration to 0 to 60 times. So it's my responsibility to make sure that the car achieves all those performance metrics on time and ready to go to launch to production. Before that, spent a number of years in the ride and handling space, working on vehicle dynamics. So really tuning the suspension, worked on the Cadillac XTS, CT4, CT5 V series, and a future flagship, highly complex product called the Celestic is on its way. So had a very diverse background here at GM so far. My entire life, I've been involved in motorsports. Spent time as a kid in karting and then moved up to modified late models. And then now I own and race a 900 horsepower dirt sprint car, which you see down on the lower right there. Graduated from Texas A&M, was involved in SAE my entire time there at the university, and capped it off my senior year by winning the hybrid competition. So I know exactly where you guys are sitting right now.
Similarly, myself, Bill Wise, like Tom, I spent all my time in school doing FSAE, so I've got a lot of experience as well. Since then, I do a lot of open wheel road racing outside of work, and then professionally, I've been involved in the vehicle dynamic space my entire career. Bounced between chassis controls, so active systems like ABS, traction control, stability control. Done the hardware side, springs, bars, dampers, and then back currently doing controls work currently on the C8 Corvette.
Okay, so to get started in the meat of the presentation here, I kind of want everybody to get their mindset around your car is now built, right? I know you may not be there right now, but moving forward, your car is built and we're looking to start testing, right? So how do we do that? What's the mindset we should have? And the key is getting as much accomplished in the shop as possible. You want to maximize your time at the track, whether you're reserving it or having to rent it. You don't want to spend time at the track doing things like test fitting the driver and checking the seat belts or bleeding the brakes, right? We want to do as much as we can in the shop as possible ahead of time to maximize your time at the track. Another key item in preparation for testing is assign a team member to kit up all the test supplies and the tools, right? So have your tools organized so they can move from the shop into the trailer and that they're available at the track. Make sure you have all your instrumentation set up and ready to go so you can pull it out as quick as possible. Have your extra fluids and tires and everything on hand. You really want to think, how do you want your pit area set up at the track, and how are you going to operate while you're there? Do we need scales? Are we going to scale in between test sessions? Do we need a tent because it's going to be 100 degrees or something like that? So kind of put your mindset around, you're at the track. What are all the items I need to get the test session accomplished, so that way you're not running between the track and your shop and wasting time that way, right? Another big item is creating a very detailed maintenance checklist in between test sessions. This is very important that way you're catching any sort of small failures ahead of time, and that way they don't ruin one of your test sessions. So making sure you're, torquing and checking all the lug nuts, checking your fluids, greasing and your hubs and looking at all the bearings, and just making sure you have a very detailed and methodical checklist for maintenance as well. Okay, so now when we're at the track, if there's anything you learn from this slide, it's treated as a business trip, right? We're not going there just to have fun. While it is fun, don't get me wrong, and I like watching fast cars as much as the next person, you want to treat this as a business trip. So you want to go there with key objectives defined that you want to achieve by the time that you load the car back into the trailer. So what is my goal from each session on the track, right? So how many hours you've either rented or reserved the track. Try to plan out how much testing you think you're going to get accomplished, and then break it down into test sessions and what we're going to do in each session, whether that be camber setting on the first one and then damper tuning A versus B on the second session, and then so forth from there. That'll really lead you to higher, success rate of actually getting quantifiable data out of each test session. And one way to get, have everything run much smoother at a test session is assign roles to the team members, right? So have a crew chief who's in charge of that test plan and make sure that it's getting executed in order and in line with what the team has agreed to before the test. That crew chief will also be the single point contact for all the note taking and all the tuning that's going to be done. That crew chief kind of maintains all that. You'll have a car chief that is maintaining the vehicle in between each test session and making sure that the vehicle's healthy, right? Are the fluids topped off? Are the brakes performing correctly? Do they need to be bled by chance in between sessions? Making sure that that's getting done. Making sure that the tires are fresh and if they need to be swapped out. And then that's where the crew comes in. The crew's extremely critical, making sure that all these things are getting done in tandem, as the crew chief and car chief are trying to make sure that all the, the I's are dotted and the T's are crossed, but the crew's the ones doing the hard work, right? And then a data analyst is hugely critical in today's day and age, right? Making sure that the instrumentation is running correctly and that they are the ones pulling the data and the single point contact for everything data related. All these roles, hugely important. That's what makes the test session more efficient. So now that we know how we're going to run the test session and we're going to get a bunch of data and we've got all this note taking, what are we going to do with it, right? So that's Bill's going to go over that in the next few slides on what we do with all this data that we get out of the testing.
Yeah, and that's really one of the big things here. There's plenty of charts out there on how you tune a car. You know, if you have understeer, oversteer, what knobs do what. But we're going to create a bunch of data, whether objective through the systems on the car that are logging data, or the driver themselves, which ends up being a very key component. What the driver experiences and what they feel is a big part of not only making a car fast, but the squishy bit in the middle has to be the one that makes it go fast. So one of the key one of the key things here is separating the race driver from the development driver. A race driver's got something relatively simple. They just need to go fast. Do it with some consistency, not make mistakes, and then not break their car. The development driver has a lot more added brain load that has to go onto them. But the key here is that the feedback that they provide needs to be worthwhile. So, you know, the development driver isn't always the fastest driver. There's a lot of brain power that needs to go into driving a car. So somebody that might be fast might be using a lot of their brain power to do that. So they're focused on the brake markers, turn-in points, etc. The development driver needs to be able to do a lot of that without thinking about it. And this is where, as you build the experience, mentally you can start picking up on what other things the car is doing. So a development driver needs to be able to drive the car fast and close to the limit and explore that limit, but they need to be able to memorize what they're feeling when that limit is approached. So that's the real big difference here between somebody that might be fast at going around the track versus somebody that's good at doing development work. And part of the key to that brain power is being able to evaluate as you're driving the car, what factors are keeping the vehicle from doing what you want it to do? What's potentially keeping the vehicle from slowing you down? And then we're going to kind of quantify it. So how much you think it's slowing it down? How often is it occurring over the course of a lap? Maybe there's one specific crack on a track at a specific location that causes the vehicle to get a little unstable. That might not slow the vehicle down much. You might lose a tenth or two, but maybe the car's got a bunch of mid-corner understeer where you're losing hundreds of seconds, but you're losing a couple hundreds of seconds in multiple places over the course of a lap. That's something that you would want to improve. So being able to mentally keep track of those is really the key to the development driver. And then being able to evaluate how you're driving around it. So like on a corner entry scenario, maybe you're having to trail brake super deep because you can't get the car to turn. So you're keeping weight on the nose. Being able to mentally keep track of that and being able to relate that back. Say mid-corner, you've got some mid-corner oversteer, or here in this case understeer, where the driver is really having to wait to get to the throttle. Is it every corner? Is it only the low-speed corners? Is it right or left? Do you have an asymmetry in the car? These are things that what we're going to get to in a second is the way you track this subjective data and overlay it with the objective. So the data you're pulling off the car is hugely going to enable. So being able to take the notes and then turn those notes into value-added changes is the key. And especially for FSAE, because a lot of teams and drivers are inexperienced. I mean, these are incredibly high-performing cars, way beyond a lot of what most people might be using even on the average track day or autocross. So personally, I like to simplify things, and this is something I use a lot in development myself. We've got several radius, and it's a GPS view, and it might be a little hard to see, but we have at our testing facilities a couple different radius skid pads available to us, and you can use these for a magnitudes of thing to pick up and look at vehicle behaviors, not only from the steady state, and do max lat and grip evaluation, but you can also use them to look at corner entry and corner exit behavior. So in your mid-corner state, when you've got very little input in the vehicle, very similar to how we measure it in competition, you can quantify your grip levels or your AY. So a car that's got a bunch of understeer, you're saturating the front axle, is not going to make as much grip as something that might be a little bit more freed up. But I think more importantly, if you remove those cones, and this is something that's pretty easy to do, if you take a couple people, a length of string, and some either kid sidewalk chalk or some drywall and trace out a circle. So someone stands in the center and the other person walks around the outside of the circle, tracing a path on the ground, something that a driver can see. You can use that visual not only to create a max lat skid pad, but then use that as a marker to indicate a driving path. So on a corner exit case, look at when you add power, say you add 25% throttle, how does the vehicle respond? Does the car immediately wash out? Does the rear axle immediately give up grip? What happens when you go to 50% throttle or 100%? Being able to evaluate how the car responds to throttle tip in is a good way to use a skid pad as a tuning metric for your corner exit behavior. And then as you add power, what happens if you reduce steering angle and you give some capacity back to those front tires? Do you go from understeer to oversteer very quickly, and evaluating that balance? And the same goes for corner entry. You can drive at that arc from a tangent, so at a straight line at that arc, and then you want to try and, so off your straight line, and then you want to jump onto that curved path. What happens is you try to change direction as you increase the steering. What happens if you break into that corner and as you start trailing a breakout? How does the vehicle behave there? And then various vehicle corner radii. So different radius, what happens as the speed goes up? Do you have some aero benefit or CP movement that is hurting your ability to make the car go faster at higher speeds, or lower speeds is giving you a push? Or even some of the steering geometry effects that might not be influenced at low speeds when you have a lot of steering in the car. But as you take that steering out, you get higher radius corners. What happens there? So that's kind of the test method here that I'd like to propose.
Hey, Bill, I got a question for you. When you
Yes.
were in Formula SAE, and you had to do this at your school, I guess this is a question for Tom or Bill. Did you just like rent out a part of the parking lot at your school, or did you go to an actual facility that had a skid pad?
So it was surprisingly hard to find a facility that would let us do this. We did not have any connections to professional facilities outside of a couple of manufacturer facilities. I went to school in Cincinnati, so Honda's facility in Marysville is a couple hours from us, and then Akron is the home of Goodyear. There's a couple more hours. But what we actually did is we found an off-campus facility that had a parking lot that they were willing to effectively let us use off hours on the weekends that we would use for testing. So finding maybe a low usage campus facility, just a parking lot that they'll let you mark up as a skid pad would be what I would propose.
Okay, thank you.
Yeah, we were able to reserve like an old deserted runway, believe it or not, near A&M's campus. So that's how we would usually accomplish testing.
Wow.
But yeah, to back up what Bill had to say with the skid pad, it's a great, first initial tool to use to really evaluate vehicle balance. And then also for the drivers, so they're not using all their brain power to memorize the new track or memorize how to get the car around the course. You can really focus on just how the vehicle's handling and not so much on getting around all the various cones that a full course would entail. So very powerful tool.
Yeah,
Okay.
Tom, that's a very good point. You don't have to learn a new course. Skid pad's always the same.
Yeah.
Speeds things up.
What size diameter would you think would be beneficial for most beginner teams?
So I would start with the defined skid pad in the SAE rules, obviously, since that's going to be one of the events. And I believe it correlates to one of the smaller corner radiuses that are allowed in the endurance and autocross tracks. And then there is a definition in the rule book of the largest radius. I wouldn't necessarily propose using that. You might be space limited, but something close to it so that you can get the both ends of the spectrum, the big radius and the low radius, and then everything in between.
Okay, thank you.
So we're going to run this test on a skid pad. We're going to get data from the vehicle, and it's going to tell us what the vehicle's doing, but we need to be meticulous about what the driver's doing and what they're feeling. So this is the key to the subjective side of it, and then how we're going to relate that back to the objective side. It doesn't matter how you take your notes, and I've got a couple examples here. One of them's at the bottom. You just need to be consistent, and whatever method you use, you need to always use the same method so that you have consistency across it. So in the bottom here, this is a actual screenshot from a test we ran recently at an off-site facility. It's always good to keep track of track conditions, time, driver, what the objective of the test is, what the vehicle state is. So new tires, used tires, brakes, you have new brakes. And then I like to tie the data file directly to it. So you come off the track, you pull the data out, you have a data file, and who knows if you're using AIM or Motec, there'll be some file name. Correlate that file name. You don't have to name it something special. It could be test number 1, but as long as it's tied to that that session run, you then can tie the notes part of that back to the data file. So if you need to find something later on, you experience something and then, hey, did we ever see that before? You go read your notes and then you can tie it back to the data file. For inexperienced drivers and inexperienced teams, it's very good to limit the number of variables you're changing at a time. And it's worthwhile to do sweeps through those variables. So if you're changing an anti-roll bar, iterate through all those positions in one go, and then do one step at a time. So then you have the notes and the data to correlate to it. Because if you start changing too many knobs, you'll never quite have the confidence of what exactly did it. And there's a separate goal here, is to create a library for yourself so that you might know later on what your tuning knobs are and what their magnitude is. So in an example here, my local road course recently repaved back in 2019. It was super bumpy beforehand. It had concrete patches and the car liked to skip all over the place. So you'd run it really soft with not a lot of damper control. Well, when they repaved it, it became glass smooth and it was glorious. So in a formula car, you can run the car very low and very stiff. But at the time I had no idea where I was going to land for ride frequency, spring rates, and ride heights. But I had enough historical knowledge that I knew, based on a targeted roll couple distribution that worked before, I could target that same roll couple distribution, do the analytical calculations, and figure out for a given spring and bar package at a certain ride height what the combination of roll center height, contribution to the anti-roll moment, and the ride rates were to get the same roll couple distribution, and the car actually rolled off the trailer with a very similar balance on what was effectively a completely different track. So that's one of the big goals here with notes, is to have a library later on so that you can reference changes quickly. So another style, this obviously works more for permanent courses. We had a go-kart track that was about an hour and a half from Cincinnati that we would use a lot for testing. And it was beneficial because not only would they let us run and it was cheap, but it was the same course every time. So similar to the skid pad, we were always running the same course. So something like this might work, where you can relate different corners to different vehicle behaviors and have a library of notes that way. This would also work if you wanted to bench bucket your courses into corner radiuses. So a constant radius corner at a given duration, you might be able to do it that way. So this is one option. A secondary option, one that we use a lot in our work, this is more targeted at overall vehicle performance, but there's parts of this that are worthwhile. This is from a roll bar test, anti-roll bar, we call them stab bars, for a production option. There were three candidate bars with different rates, and there's an objective measure that is scored. This is scored at a 1 through 10. You could score this 1 through 5, 1 through 3. But the goal here was creating a scoring sheet such that you've got something to compare against and relate subjective notes to. But I'll jump here. More specifically, the scoring side of this. In this example, the bar number 3, the one that scored at 7.19, was obviously preferred slightly than the bar that scored at 7.12. It's a very small, minuscule change. But what ended up happening was the bar number 3 was not a production viable solution. Long story, but basically the supplier couldn't make that bar. Well, I didn't have the time. This decision was made in December and the test was run in October, and I didn't have the ability to go out and run in Michigan in the snowy road course and get the comparison between it. But I was able to use my notes and go back and find that there was a production solution that was very close. There were some trade-offs one way or the other, but I understood what those trade-offs were, and I was able to make other tuning compromises to basically end up at the same package from an overall vehicle performance level. So that's where keeping some notes and having a library of knowledge is very beneficial. Say you break a roll bar and you've got these 2 other bars in the trailer and you don't remember which is which. You can go to your notes and you say, you know what, we didn't like this other one. It had some benefits, but they weren't worth it. This other one's closer, and be able to make that change with some confidence that you're picking a solution that's going to get you the most performance out of the vehicle. So you're going to run these tests, and then one of the big things is you're going to either car's going to go faster or going to go slower, and you always need to revisit that baseline because you need to know whether the changes were doing it or the track was doing it. Tracks are going to rubber in. Say you use a parking lot, it could be dusty and dirty, and after 5 hours of running, you've cleaned it off quite a bit such that the track has gotten significantly faster. You need to understand that so that you have a metric to compare against to know whether your changes are actually better or worse. In an ideal world, you go back to your original configuration and it was the same as your baseline, but that's not always going to happen. Our road course at Milford on a summer day will slow down 2 seconds from 8 a.m. to 4 p.m. Just from sun load and temperature increases. So you get a significantly change. You'll evaluate something in the morning and it feels great and it's super fast. And then if you went back out there at the end of the day and you didn't know, all of a sudden the car's super greasy and it doesn't want to do the things that it was doing earlier. It's not behaving, the balance is going away, and it's slow all of a sudden. Well, you need to know. So in that case, if you go back and use your baseline to validate your changes, it'll give you a lot more confidence in what you've learned throughout the day.
Yeah, because usually at that point the driver's complaining, and so to the crew chief, if you just took it at face value, you would just assume that whatever change you made was not good, right? But in reality, something else may be changing outside of the car. So it's important to go back to your baseline.
Yeah, and we've seen this across days. I had a trip to the Nürburgring a couple of years ago. We ran all week, the first week of industry pool, and then on the weekend in between, there was a local VLN race, which is their local endurance series, and they ran a 6-hour race on Sunday. Well, when we went back out there on Monday, a car that was good on Friday afternoon was suddenly terrible.
Sure, right.
Yeah, didn't want to put down power, it wouldn't turn, and like we were pulling our hair out going, this was good a week ago, we got to start over. Well, by the end of the day on Monday, the car was good again once a bunch of street cars had run again. So always make sure to go back to your baseline, especially if you end up with weird answers or weird something weird changes and you're not sure what's going on. Go back to a known good point and compare against it. So now let's do a quick little kind of case study on comparing objective data to the subjective. So we've done this subjective comparison here on how you take your notes and how you want to keep track of what the driver is feeling. Now you need to relate that to objective data because the drivers are fallible, and certain drivers will prefer a certain thing, a certain package, a certain driving style, and another driver might not. So you need to be able to relate that to objective data to make sure that you're still going in a good direction. So in this little mini case study, there's a program I was working on where we had some drivers complaining of mid-corner understeer with a proposed tuning package. So went back, had 2 proposals of things that free the car up, make it feel a little bit more agile, makes the car more neutral mid-corner, and then we did a very we were running new tires on each package. So the study was, we were trying to minimize variation between each package so that we weren't evaluating tires or track variation. So we ran 4 consecutive laps on each package on a new set of tires. And on this one, you can see the objective data, the goal being, you know, to make a car fast. The objective data, the lap time data, gives you a pretty straightforward answer. So it's often the most enlightening, but it's not always going to provide the same picture. And it is possible to have this go backwards, where a package that is objectively faster might be much harder to drive. So we're going to look real quick in a couple methods that I used on this study that compare, you know, what the vehicle's like to drive, maybe over a single lap versus multiple laps or a longer duration. So the baseline package A, what we're looking at is a trace between 2 constant radius, long duration sweeping corners, one left and one right, speed trace, and then a channel that I like to use, which is an understeer channel, which is basically the variation between the driver or the vehicle actual steered road wheel angle versus the Ackerman calculated neutral steer. So you can see this is first lap versus the 4th lap. They're relatively similar. There's some variation where by the 4th lap, the car starts to use up the tires. So it does get a little bit looser, but in general, the subjective note said that the vehicle was pretty consistent over the run. There weren't significant changes in the subjective performance, and the vehicle was driving very similarly. Now, using the same method on the 3rd combination, using these same signals, hope the color's okay. It's a little tough to see that bright green, sorry. The darker trace being the 1st lap and the lighter trace being the 4th lap, a vehicle that was relatively similar for lap 1 performance to the baseline package. So the car was pretty benign, became quite a handful by the 4th lap. You can see the deviations in the understeer, particularly the quick deviations, which correlate to driver correction due to oversteer, is significant. And the subjective data match this in this case. But this is also a case where the drivers that were complaining of mid-corner understeer saw this potentially as a benefit from their subjective evaluations. But in this case, obviously the lap time being the big indicator, we didn't want to make a step back. But this is where one driving style versus another might give you a different answer, where overlaying objective data and understanding why that preference exists will give you some better understanding of what your vehicle's doing. Another way to do this, this is just a quick channels report that I use in the AIM data system. Again, the same test. You can actually see the vehicle fall off from lap 1 to lap 4 and see why packages B and C had subjective comments of degrading faster. The 1st lap versus the 4th lap has degraded significantly quicker on packages B and C than package A. So this is just another option. I like this personally because it's a real quick look. Don't take this at face value, particularly because a lot of the way you calculate this will matter to how you evaluate this. So just be careful with understanding the math behind some of these channels when you do it. Understanding why you're calculating it and how you're calculating it is beneficial to your understanding of it. So in the FSAE environment, make it fast, especially for inexperienced drivers, make it easy to drive and make it repeatable. So consistency makes things easier. A car that's not changing balance on you over the course of an endurance run will take a lot of mental load off the driver and make things easier on you. And then just a little bit of tidbit from what I learned, not only from FSAE, but just kind of in the performance world in general. There is a mantra out there that loose is fast. And to an extent, I agree with that. But loose is fast through the middle of the corner, where the yaw rate, the max rotation is important to the car. In say a slalom, the agility, the ability to change direction is important. But this is where, go back to the skid pad, you can make a big max lat number that can be very difficult to drive in transition. So a car that's good in transition needs to have some inherent stability. So get that max lat number and steady state yaw rate to be as much as a driver can stomach, and then use your dampers to help stabilize the car. Generally speaking, the driver inputs that induce weight transfer that stabilize the car, those same motions can be used on the damper side to stabilize the car as well. So a vehicle that's good in a slalom might have some ability to stabilize when the driver tips into the throttle. So when you take some weight off the nose, put it onto the rear to give you some grip on the rear axle. A vehicle that has a damper package that's tuned to also add some of that stability on the rear axle will further benefit the driver's ability to make that car go fast. So just a little piece to maybe focus on when you're doing that tuning and development. Think of kind of those two concepts.
Yeah, great point.
Teth.
Okay, so everything we're telling you, you may think this is, FSAE focused, and that's not the case. I've spent the last couple of years now working on the virtual future side of the house within GM, and we do have hardware set up on benches that we're able to articulate and actually and move and test. And then we have a driver in the loop simulator. So if you look at that picture, that's a cockpit up on electromechanical actuators, and you're able to sit in the cockpit and drive, and there's a screen in front of you showing the mapped out course that you're on, and the car sim is providing inputs to move that cockpit or buck around, so you can help tune the vehicle virtually, right? So you don't need physical vehicles that cost a lot of money to build. But what we found, at least what I found here, is all the same fundamental vehicle development process is still involved. You still need to be extremely organized and take notes. The amount of effort that it takes to update the model of that vehicle to be correct is monumental. The amount of team members and the amount of data. I think we were looking at one just a few weeks ago, and they had over 400 variables, specific vehicle variables to go over to make sure that they were correct. And a lot of that was driven by me, because I was driving this simulated vehicle and it just did not feel correct, right? I would float over some of these bumps, and then, on the screen, I should have landed, 10 seconds ago, and then I would feel, an impact through the simulator. And we had a deep dive to figure out what was going on. And sure enough, instead of the wheel accelerometers being, XX millimeters behind the CG, they were meters behind. So somehow between the software updates on car sim and our simulator, the units had changed. And it sounds so simple, right? But it made a dramatic difference, and it basically tanked, 2 days of testing to get that figured out, right? So it's incredibly important to stay organized. Make a list of what you plan on testing. How are you going to objectively quantify that data that you're getting? Especially with all the virtual world now, with that simulator that you see on the screen, you can get a lifetime of data in 2 runs, right? In an hour, I can have all the data I'd ever wanted in my life. But it doesn't matter unless I know specifically what I'm looking for, right? So just walking around with charts doesn't mean anything unless you know exactly what you're looking for. How are you trying to make the vehicle better and faster? So hugely important. The base fundamentals are the same. We're still changing one thing at a time. I'm not changing multiple things on both ends of the car. Even in the virtual world, we're still sticking with one thing at a time, trying to quantify what each of those changes actually mean. And then how can I use those learnings when the real physical vehicles show up? So now we're building less and less physical vehicles, but that's because we're doing all the hard work in the virtual world on a simulator like this up front. But again, we're using all the exact same principles that we just went through here in this. So And same thing, just like what Bill was saying, is you know, when you're working the simulator world, it's even more important to be extremely consistent and smooth as a driver as well. This is another huge principle, and be able to provide very specific feedback to those in the control room on what you're feeling. It's a key attribute. Otherwise, you know, you're just playing a video game at that point if you're not really getting actual learnings out of it. So all these fundamentals that we've taught today are extremely important, especially as you guys move into the career in the automotive world.
So I think we were a little afraid that we'd get through it'd take too long, Matt, but I think we got
Yeah.
benefit here for questions.
Yeah. I have a couple questions for you. Just a reminder to everyone, please use the chat function if you do have questions. I am watching it right now. I'd like to know, how did your teams, your FSAE teams, pick their drivers? And I guess, do you have any good suggestions on how they should be picked? I know back in the day, basically whoever had experience at my school, you were the driver.
Yeah, that definitely plays into it.
Yeah.
We always try to get people as much seat time as possible, especially early in the year. So we would start in the fall and we would use the previous year's cars just to get people experience. And we try to keep those cars running as long as possible. And then in the springtime when we were doing testing, so the experienced drivers would do the testing. And in hindsight, knowing what I know now, I did a lot of that testing myself and I had no clue what I was doing. And I was driving a lot of laps trying to figure it out. But in the meantime, we were using those old cars to give people experience. And eventually, you would find people that you basically end up with a handful of people who are the quickest. And then we would kind of shoot out for each of the events. Whoever's the quickest in each event would be the ones that would be selected for drivers. And it just naturally kind of fell that the two most experienced drivers almost always did on my team, endurance and autocross. They were also usually the fastest because the experience definitely helps. And then whoever was kind of in that short list of the quick people, they usually ended up being the better candidates for the Excel and skid pad as well.
Okay.
Yeah, very similar. You know, at A&M, the underclassmen usually were responsible for keeping the older cars running, which is extremely important, especially what I know now. I mean, it's important to have, you know, somebody working to make sure that those older cars are up to date and running. And we did the same thing. You know, we would train and test as much as possible in the fall, evaluating different drivers and getting them seat time. Seat time is everything, you know, from grassroots all the way up to the professional level. Seat time is everything. So getting as much seat time for everybody as possible. Usually those who were working the hardest always seem to be the ones that got the most seat time, right? That's just the way it shakes out. And we did the same thing. You know, by the time the spring rolled around and you had the physical car, or this year's car, we would do a shootout. And for us, it usually was the most experienced guys. It's, you know, I had a resume going into it and that kind of helped me. And that's just because I had so much seat time, right? Before FSAE was even in my life, I already had a bunch of seat time. So that's just a key part of it. So that's where keeping those older cars up to date is a big, you know, a big aspect of being in competition. And then, yeah, I think acceleration, though, we usually did reward somebody who maybe wasn't the quickest or most consistent driver. We would, you know, give them the acceleration seat just because they were like the hardest worker. It was kind of something that you would have to earn, right? So that's kind of how we treated that.
Okay. All right, that's awesome. Do you suggest going to a local like go-kart track with, I'm not talking about it if you have a formula car, if you don't have a formula car, maybe make an event. Is there any value in going to a indoor go-kart track during the winter time?
Yeah, find the local rental place that for 20 bucks a session you can go run and take all your buddies. And we used to do that. There was a kart track about 30 minutes from Cincinnati, and we would go like once a month or every other week on a Friday, there'd be like 10 of us and we'd go have a blast. Go-karts are a great training ground, especially for FSAE cars, because the limits are similar. And to go fast in a go-kart, you have to be super smooth with your inputs. And then like simulators have gotten way better now. Like I remember spending a lot of time on Gran Turismo, but now with like iRacing, you can get tons of seat time for $20 a month nonstop. So there's lots of ways to get seat time and experience. Anything you can do to learn the driving aspect is better than sitting and doing nothing.
Yeah, karting was a huge way that I started. Definitely a great way to get seat time. And then, you know, just as Bill was alluding to, iRacing is now huge, and certainly the best simulator there is out there right now, in my opinion. Even when I, you know, left Texas and moved to Michigan and didn't have any money to go buy my own race car or even have enough money to go rent any karts, I got iRacing, you know, the most basic setup you could to run iRacing at the time. And that's what kind of kept me, you know, kept my hand-eye coordination up and everything until I was able to go buy my own, you know, car outside of work. And then eventually I moved out to Milford and was, you know, testing the high performance cars as well. So yeah, I mean, if you're a true driver and you really want it, you'll find a way to get seat time. It's possible.
Okay. All right. Another question for you guys. What channels of data from the acquisition system do you consider to be the most important? I guess, Bill, do you want to go first?
Sure. The inertial signals, lat long, yaw rate, speed, GPS speed, those kind of, those three at a minimum, the lat and the long and the GPS, and then driver inputs, steering, throttle, brake. You can do a lot with those.
That's all you need.
Yeah, that's all you really need.
In FSAE, that's all you need. I mean, that's still the core of what we do, right? I mean, that's the basic to really evaluate balance is those are the core signals for sure. But then, yeah, Bill, if you let Bill talk, he'll go on for a day on data signals. So be careful what you ask.
There's a couple good books out there, and I wish I could remember the names off the top of my head. I want to say one is by Jorg Seegers. It's an SAE book about data acquisition, and it's got a woman. I think the version I have is got a woman pulling data off a NASCAR maybe. There's a lot of good stuff in that one that relates to the mass signals. There's a lot you can do with just a few signals to learn about, you know, not only what the car's doing, but what the driver's doing. So I would say with a handful of signals, you can do a lot of damage.
Okay. All right.
My advice is keep it simple when you're starting out for sure. Because you can, like I said, you can bury yourself in data, right? So that's the key is keep it simple.
Bill, do you happen to know the title of the book I'm being asked?
Oh, yeah. Yeah, let me pull out technology and
okay.
see if I can find it real
Well,
real
while you're doing that, I guess the last question that I have for you. So if anybody else has any questions, please make sure to use the chat function down below. I guess, Tom, I'll start off with you. So the teams have been prepping, they've been going to their skid pad. They think the car setup is best as it's going to be. They get to Michigan. What should the driver do? Obviously walking the track is very important. Is there anything else that they can do when they get to the parking lot or paddock? You know, what can they do to prepare for the track that is there?
Yep. So from a driver's standpoint, you know, you want to walk the track, obviously, memorize it to the point where you're able to draw it, you know, on a piece of paper, blank piece of paper. And that way you're thinking about it as you fall asleep at night in the hotel and you wake up and you're thinking about it and you've got it memorized. You've planned out your braking points. You think you know how you want to enter the corner to hit your apex correctly. That, you know, that's all on the driver, right? There's a lot of homework that you can do right away as soon as you show up by studying the track, walking the track, you know, drawing it down, and really live, eat, breathe, sleep it. That's all, you know, on the driver, and something that can be done very easily, you know, without a whole lot of extra data or anything like that. For the team, you know, it's just like I was saying, is making sure that, you know, you've thought of everything that you had at your test sessions. You know what you need for competition. You've made a very detailed list. You've packed it all in the trailer. You've got it all there. Just making sure your team is organized when you guys show up, right? That you're checking the fluids again. It's amazing how a race car is just like a boat. Anytime it sits, for some reason, things fall off, or the fluids get low, or the lug nuts need to be torqued again. Just make sure you're going over it with a fine-tooth comb based on that maintenance list you've built up between test sessions. You can bring that, you know, to the competition and go over everything one more time and make sure everything's set up. And then, you know, it's getting ready and really using that test track, right? So it's been a few years since I've been to competition, but the test track was always open and available, and make sure that your team is ready to go, right? That you're ready to get through tech, that you don't spend the first full day going back and forth to get through tech because you weren't prepared. You know the rules like the back of your hand, so that way you can get through tech the first time, and then you're the first one on the test track shaking down your car, you know, on the surface that you're going to race on.
Great response. Bill, I noticed that in the chat you've added the title of the book.
Yeah, it looked like 2 other people figured it out too.
Technical or analysis techniques for race car data acquisition. Yep. I guess, Bill, would you like to comment anything further off of what Tom said? You know, you get to MIS, you think your car's it's been set up perfectly at your home or at school. Now you're ready to walk the track. Is there any last minute things you can do before acceleration, skid pad, endurance? Is there anything you could think of?
I guess as so I did a fair amount of driving because by the time I was a junior, it was my 3rd and 4th year already. Cincinnati was a 5-year program, by the way. I wasn't there 5th year by choice. So the way it ends up shaking out is, at least on my team, is I was team lead the last year, but I was also one of the drivers, so I had a lot of responsibility on the car and the driving part. But there were enough people that I had confidence in as the team lead and as a driver that I basically kind of went away and I was focused on just the driving part. So once my events came up, if I wasn't required to be working on the car or getting it prepped, I tried to go hide away in the trailer and just kind of focus my mind.
Okay.
Especially then when I've had much less experience than I have now. I don't have to be as dedicated to focusing on the driving side of it now. But as a young engineer and driver with not a whole lot of experience, being able to just focus on the driving part. And then don't psych yourself out of it. Like, you can work yourself up into, and then just
True.
when it comes time to do it, you just kind of get the nerves. So focus, but don't be try not to drive yourself into an anxious, nervous wreck.
All right. Thank you very much. I'll wait another 2 seconds here for any more questions before we move on to our next couple slides. All right, I don't see anything. If you could move to the next slide for me, Bill.
Yep.
All right, I just want to go over some upcoming events. So February 11th is our next Formula event, cost event overview with Richard LePage from Ford Motor Company. And then February 18th, another Friday, it's the presentation event overview with Adam Zemke. Please register at the link down below, sae-detroit.org. You will get a personalized Zoom link, so make sure you use that when you log on to the event. You will get an email for it. And then if you move to the next slide for me, Bill, Engineers Week is coming up for 2022. SAE International is hosting daily events that you can see on the screen there. Please make sure you go to sae.org/participate/Engineers Week 2022 to sign up for these events. If you volunteer, you can win a pair of Apple AirPod Pros. So please go ahead and do that. And then the last slide for me, Bill. I just want to thank everybody for joining us today. Thank you to the participants. A special thank you to our presenters, Tom and Bill, the SAE Detroit section staff, Alba Cologne, for your involvement in putting together today's presentation. Please remember to join us for that Formula SAE cost event overview on February 11th. For any questions or inquiries, please send an email to the SAE Detroit section at events@_sa-events.org, shown on the screen. If you're watching this on YouTube, please consider liking this video, sharing it with someone who might find it useful, and consider subscribing to our SAE Detroit section YouTube channel. Thank you and have a great day.